backside until now, and I was very curious to hear from you, especially given that you have a lot of experience in developing these models, training these models. You've written it, you have, I think in earlier companies also, you have worked heavily on fraud detection and other areas as well, using such models. There was one problem statement that I was very curious about, and this comes from my recent, so in the last couple of years I was also going through some of these cases where AI actually failed. For example, people were successful in fooling the AI. So there was this experiment that a bunch of researchers from Tencent were doing on Tesla Model S, and Tesla Model S is AI enabled in a way. The system that within Tesla Model S was lane detection system. To us, to normal humans, it'll feel like okay, for detecting lanes now you have an entire model, and because you need that, because the way lanes are painted, the depth of it, and the way they diverge from each other, all of those things change, and they change between countries also, right? So that's not uniform. And they were able to fool it by having stickers on the road, and were able to actually confuse it to an extent that it started misbehaving, and the car was moving here and there. And the Model S, which was AI enabled, essentially could not perform and could not have detect the lanes correctly and kept moving here and there. So in a way, they were able to fool AI in that case, and there are many such cases where these experiments are happening. So I wanted to understand, in your experience of developing these systems, how do you actually understand that these edge cases will be there, and also how to secure your ML models?
Okay, that's a very interesting question. I would say I don't have a straightforward answer to that, to be honest. I can share my experience.
Okay.
So basically, there are two parts to this problem. First part of the problem is AI gone wrong, right? So where basically uh, there are multiple things, rogue AI and other things we can say. But then the idea is basically one part is yes. Um, so basically, how do I put it? So basically, there are okay. So basically, to answer this question, so there are two parts to this problem. One part of the problem is, I would say, the way I see it is, one is obviously the data problem, in terms of you don't have sufficient data probably to train the model. Otherwise is adding noises. So I'll explain what is the problem. What does this mean? So if you let's take about this lane problem, right? So lane problem could have been in two ways to look at it. Let's say you have trained only with data where the lanes are on the left. The car's supposed to be on the right side and driving.
Mm-hmm.
And if you try to use it on let's say a country like India, where the car's supposed to be on the left side, right? So it's tricky. It is biased. It is not trained with the sufficient data. So sometime what happens is the use case for which has been trained, it's not trained with the right data, and as a result, it has certain kind of biases. And we've seen a lot of example like that. And one of the example is racial bias, which is pretty big concern in a lot of cases where,
Uh,
let's say, if there is certain kind of so there was an incident I remember in the US happened. There was a Department of Justice was using an AI model where it's supposed to predict a convicted person who is, let's say, faced his or her time and got released. What is the probability of that person committing a crime again? And it was, the model was unfortunately trained with a lot of biased data, and as a result, it was more biased towards dark skin people, saying that they have more probability of committing crime versus a person with white skin. So these are the various things was there. It is also basically the problem of the person who was designing the data science, or the engineer, whatever you call the person who was building the model. Is this person have thought through all possible use cases or not, and then has sufficient data for that or not? The other point what you're talking about is, if there is certain limitation, because see, at the end of the day, there will be limitations. If there is a limitations like this, and the use case you're talking about, this Tesla, where people are putting stickers and stuff like that, these are called adversarial patches. So lot of this kind of stickers available. What it does is actually looks like a pixelite sticker kind of thing. And
Okay.
if you wear it, and when the camera actually looks into this, and this sticker is there, it has sufficient noise which is feeded into the data. And as a result, the model was not successfully able to predict that.
Actually, there is a lag. Maybe we'll just take a minute and we'll resume it. There's a lag in, ha, now I think it is in your video and what you're
Is it okay now?
saying. Yeah, just a
Now,
second.
no, but no. Can you
No,
see?
it's
Is it working now?
frozen, it's freezing बीच बीच में. I think it's the network.
Oh, maybe it's
Can
a
you
network.
just a second?
Yes. So basically, this, as I say, then one is a bias problem, which is really popular, and this bias problem comes with obviously the people who are designing with have they thought through all possible scenarios and having sufficient data point for that. The other one I was talking about is how do you fool a model with this sticker or patches? This is called adversarial patches, which is pretty popular. You can Google for it. It's called adversarial patch. And there are multiple use cases for that. People actually create a t-shirt around that where there's a t-shirt with a sticker. And what it does is this has enough kind of data like a noise, which is actually feed into the data frame of, let's say, a computer vision model. And when it's treating this, it actually gets confused because of that. I'm not getting into the
Oh,
technicality of how exactly it
interesting.
happens. Yeah. So basically, the way it happens is, yeah, let's say there, if you Google for adversarial patch, you can see that there's a model which is supposed to do object detection. And let's say there is a toaster and there is a banana. And if you put a patch next to the banana, it detects that as a toaster. So banana is identified as a toaster,
Oh.
just putting a sticker next to a banana. There is a use case where people actually was doing like there's a T-shirt which has the sticker, and
Mm-hmm.
if you wear that T-shirt and go through a mall or wherever there is a human detection, like there's a camera which detects that is a human being which is walking through the passage or whatever it is, you actually can get undetected because of the patches. So
Oh, wow.
so essentially, these are all various adversarial patches there. There is also an incident where this patches actually kind of convinced a self-driving car as a stop sign, and the car stopped in the middle of a road because it thought there is a stop sign because the guy was walking with the sticker was walking through the footpath of
Oh,
the street.
okay.
So these are called adversarial patches. So which is actually created by another, let's say, a machine learning person who understand the model and create this in such a way that this is called noise. You add enough noise to the data so that it misrepresent or detect as a wrongly identified object.